the distributive property, when it works and when it doesn't. So we're all familiar with this case, even if this example is a little bit over the top. And so basically what's happening here is we've been told to multiply that number into each of the separate terms. So basically multiplying it in once, either side of each addition or subtraction. Now, you may have seen a diagram something like this, and so you'd know that this is thinking of it as an area, and so rather than labeling that whole side as this rather long thing, then we can split it up into these three sections here, and then obviously as the rectangle's been split into three rectangles, we can then just multiply that, well, let's call it width, by each of the three lengths there. Okay, so we multiply it, and multiply it. So basically, I'm trying to put this in real simple English. What is distribution? Okay, so that's when you're showing an operation, and instead of applying it to the whole thing, you can just pick out the different bits and do that separately instead. So let's look at some examples of this. So you can do it with multiplication over addition and subtraction, division also over addition and subtraction, or you can do exponents or roots over times and divide. Now there's other examples people will start to think they can do, but they can't. Okay, so why does it work here? This one's probably less familiar to some people, but it kind of is the same idea as what we were doing just now. So let's just draw, so we can apply that divide to each term separately. So we can think of each of those terms as just being over its own 13. So what would that look like as a picture? Well, if we kind of view that as a rectangle with a side equal to 1, what would happen if we were to kind of cut it off and take a 13th as the length instead? Well, obviously each of those rectangles would be a 13th of the original size, so we could just have them over 13 as illustrated on the other slide. So let's just quickly map out how the different operations relate to each other. We've got addition, and if we repeat that again and again and again, we get multiplication. We repeat that, we get exponents. Each of those kind of has an opposite. So addition has subtraction, multiplication has an opposite of division, and exponents have roots as their opposite. So the rule I want to give you is for each layer, they will distribute, say exponents and roots will distribute over multiplication and division. Multiplication and division will distribute over addition and subtraction, but they won't do an extra layer going down, and that's going to be probably the main misconception that people have, times when they do it when they don't think they can. Also, most of the inverses, people don't realize that they can do those just the same. So let's have a look at this one, very popular at level 2 exams. So that one there, you can just square each of those, each of the coefficients, each of the variables, and so you're going to have 4 to the power of 2 gives us 16, x squared is going to be x to the 4, and y squared. And then we've got 13 squared, which is 169, and z squared. And boom, nice and easy to simplify, yeah? Now, basically what's happening there is you could just multiply that bracket by that bracket, and because they're all multiplies, you can do it in any order you like. So you put the bits that kind of naturally go together. Okay. You can also apply the roots individually to each coefficient and each variable. So you can take the square root of 4 and get 2. The square root of x squared is going to be x. The square root of y to the 10 is going to be, well, what's half of 10? Y to the 5, right? And on the bottom, you've got the square root of 81 is 9, and the square root of z to the 6 is z to the 3. Similarly here, oops, I've got the answer up already, but why can you get that? Because you can split that up into -1 times 25 times 2. You can just apply to each part separately, and the square root of -1 is the I, the square root of 2, can't really write that any other way, but the square root of 25 is 5. When does it not work? We are trying to skip those two levels, so exponents will not distribute over addition and subtraction. We'll look at some counterexamples in a second, and you can't do roots over addition and subtraction, only over division and multiplication. Okay, so just a quick reminder, this is why that won't work, because you're going over those double layers, okay, and it's because of that whole repeated thing that links each layer. That's why you can do it. I can go into proofs, but I don't think you want to see them right now. So let's have a look at this. This one here, really what you'd have to do is you'd have to expand it out and multiply that bracket by itself 4 times. So you're going to have to use FOIL, then FOIL again, then FOIL again. This is quite a hard question. Well, you could do it. It would just take a long time. And I'm not going to do it in this video. You can leave it for you. And this one here, I'm not even sure that does simplify. It sure looks like it would, but it doesn't. Okay, you cannot do the two sides of the addition and subtraction. Okay, that is a feeling that you get because you've done similar questions using distribution, but it's just not going to work. Okay, I hope that helps. Thank you very much for watching. See you again next time.